All right, for us to communicate about the max min, there's two ways that we can do this. On the homework, you will mostly see this first way where we will say the relative max is a point or the relative min is a point. So when you look at this graph here, again, you see that this is your lowest point relative for that restricted domain. And so that would be considered our relative min. And one way that we could write that is just saying the relative min is 2 comma negative 3. The other way that we can communicate about max and min is with a sentence where we say that the relative min is the y value at the x value. So the key preposition here is that word at. It always happens at the x value. So here when I have the relative min, where I have this point, it would be the relative min is negative 3, and that happens at 2. And one thing that's really important to notice is that you don't have to write the x equal to. When you just have that preposition at, whatever follows is understood to be the x value. So it is 100% clear that the x value is 2 and the y value is negative 3 from this sentence that we have here. So those are the two ways that we'll communicate. Again, the homework mostly focuses on just the point, but I want you to be aware of how you could write it as a sentence as well. So this was just kind of our quick overview of college algebra discussion. So what is a relative max, and then how do we communicate about one? In college algebra, every time you were given the graph and then you just had to like pick out the point and say, okay, this is the relative min or max. Now in business calculus, our goal is to find the max or min without seeing a graph. Now, I know everybody is sitting there saying, well, I have a graphing calculator. I can put this in on my graphing calculator. Big whoop, it doesn't matter. But here is the thing. In higher level classes, especially like in higher level economics and business applications, things get very abstract very quickly. So they are not going to be using numbers. They're going to be using variable quantities to describe things. So I'm going to talk more about that in a separate video, but just know that in higher level classes, the idea is you're not going to be able to just punch it into your graphing calculator. You're going to be using this calculus to actually analyze the theory behind what would happen in certain situations. And we'll talk more about that in the next section. But again, just a little preview, please just remember it's not just, oh, I can punch it on my graphing calculator. It's really the next step past that of, well, what happens when I want to like create some economic theory about what's going to happen in the market or what have you. All right, so with that goal of trying to identify the max or min without seeing the graph, we need to recall two things. The first thing is when we have a horizontal tangent line, you might remember in test 2 that kind of random question where it said find the points where it has a horizontal tangent. To do that, we set the derivative equal to 0. Now, something that we haven't really emphasized too much, but is just for your information, is that when the derivative does not exist, then the function is not smooth. So examples of when the derivative doesn't exist is if you have like a corner or a cusp, you have like this very like not smooth behavior or discontinuity, that's when your derivative will not exist. Now, what we're going to see is if you draw any picture that has a relative extremum, remember extremum just means the max or min of the function. You can play around with this, but what you're going to see is that it's going to fall under two categories. If it has a max or a min, either in one case, you're going to see that at that max point, you have a horizontal tangent, and when you have a horizontal tangent, your derivative is equal to 0. And that's based on our discussion from test 2. The other case that you can see if you kind of play around with different max and min pictures that you could draw is you could potentially have something that looks like this, where at that minimum point, we actually see that our function is not smooth. And that would be a case where the derivative would not exist. So again, you can play around with this. I used to like really enjoy playing around with like the different graphs, but I challenge you to draw a graph where you're not going to see that the max or min happens at that horizontal tangent or where the derivative is not smooth. And there is a very important conclusion in calculus that summarizes this result that says that if I have a relative extrema, the derivative is going to fall under one of these categories. The derivative is either going to be equal to 0 at that max or min point, or it is going to be does not exist, undefined at that max or min point. And so because of that, because at any extrema that we look at, we will see either the derivative equals 0 or the derivative does not exist, we call these very, very special points critical numbers. Now, I want to just emphasize one thing in your notes here. You guys, this part right here is just kind of a for your information. The first two pages, page 1 through page 2, are really just intro into this next section. Okay, so the two things that I wanted you to take away from page 1 and page 2 are just a quick recall of what a relative max versus an absolute max is. And then secondly, I wanted you to take away what we call that point. We would either represent it as a point or through a sentence. And then we're going to get into this very important result about critical numbers on the next page.